This video is about the STM32F4 USB Device Firmware Upgrade, or DFU, and shows how to jump to the bootloader from your application. This is a demo using the STM32F4 Discovery board, which uses the STM32F407 microcontroller. Shown here is the STM32F4 Discovery board, which we will use for our demo. The USB connection at the top of the board is for the ST-Link. The USB connection at the bottom of the board is for the USB device firmware upgrade. The black push button switch is to reset the microcontroller, and the blue push button switch is for jumping to the bootloader. We'll use ST's DFU Demo to download our applications to the board, but before we can do that, we need to convert our hex files into DFU files, and we do that with ST's DFU file manager. So we end up with two files, green LED flash.dfu and red LED flash.dfu. These are our two applications, and you can see on the board that the currently running application is the green LED flash. Notice that no matter how many times we reset the microcontroller, it continues to return to the green LED flash. If we press the blue button, it jumps to the bootloader and we can download a new application. If we select the red LED flash and download it to the board, then when we hit the reset switch, our red LED flash application is working. Now again, notice no matter how many times I hit reset, it continues to return to the currently running application. Similarly, we can restore our green LED flash by again jumping to the bootloader, choosing the green LED flash DFU file and downloading the code to the board, so that now if we hit the reset switch, our green LED flash application is running. And that concludes the board part of this demo. To generate our project for this demo, we're going to use STM32CubeMX. If we open that up and select the discovery board, it will bring up this default pinout on the pinout tab. There's nothing we need to change here, so we can move to the next tab, which is clock configuration. The clock configuration is a default HSI configuration, and that will do us fine for our simple LED flashing application. Remember that the bootloader doesn't care about the application clock configuration, as the bootloader will set up its own clock configuration. The next tab, we do need to make some actual changes. On the GPIO, we need to find PA0 wake up, which is the blue button, which is by default is configured for an event on Rising Edge and we need to change it to an interrupt on rising edge. And then we can click OK. And finally we need to go into NVIC and find that line which is external interrupt line 0 and make sure it is enabled by placing a tick in the box. We can now click OK, and we're now ready to generate our code. Okay, we've opened up the project code generated by STM32F4 and there's only two files we need to change. One is main.c and the other is the startup file, which is an assembly file, but that's the file that contains the reset handler. So first of all, let's look at the changes made in main.c. We have a callback from the interrupt. Now this callback routine is going to be called whenever we have an interrupt from the blue user switch, whenever that blue user switch is pressed. And all it does really is it sets a flag. Bootloader is requested equals 1. So whenever the switch is pressed, bootloader is requested becomes 1. Now in the main loop, this while 1 is part of the main loop, the first thing we do is just flash our LED once a second, and the second thing we do, we check that bootloader is requested flag, and if it is requested, then we load our special value into the boot check variable, and then we simply do a software reset. And that's really all the code in main.c, apart from a few declarations of variables and constants up the top of the file. The only other file we need to change is the startup file, and in particular the reset handler routine. So if we look at that, we've added in some external variables. These are the variables we've declared at the start of main.c. But when we come into this reset handler routine, the first thing we want to do is we want to check and see if our special boot value has been stored in RAM. So we look in the boot check variable and we compare it to our special value. Compare instruction is CMP. And if they're not equal, we just continue on to the main application as if nothing had happened. If they are equal, we need to load the address of the bootloader, and then from that address we can load in a value for our stack pointer, and then at +4 we can jump to the bootloader entry. And that's all the code there is. One point I could make is the boot address for the STM32F4 is common for all STM32F4s. So this should work, this code should work on any STM32F4. The other point I'd like to make is we're jumping to the bootloader from the reset handler. So when we jump to the bootloader, we're always on a default HSI clock. Now when we actually get into the bootloader, because this is USB DFU, the bootloader is going to try and configure a HSE clock. So you need to have an external crystal attached to allow it to do that. If there's no external crystal, the bootloader is not going to work. I hope you found this demo useful. If you'd like to explore this further, some resources are the application note 2606, which talks about the microcontroller system memory boot mode, the STM32F4 for building the project, and the DFUs, which includes both the DFU's demo for downloading the code and the DFU file manager for converting your hex files into .dfu files. The project used for this demo, including all source files, can be found on github.com/microready/STM32F4_DFU_demo. I hope you found this useful, and thanks for watching.